we have to evaluate this. So I'm going to use a formula that will solve it first, then I will prove the formula. So there is a formula for anything of this form: integral of sec x raised to the power n dx is always equal to tan x sec x raised to the power n minus 2 over n minus 1 plus n minus 2 over n minus 1 integral of sec x raised to the power n minus 2. So I'm going to use it here, so the solution will be fast. So I have integral of sec, our n here is 4, is now equal to tan x sec squared x over 3 plus 2 over 3 integral of sec squared x. And we know that integral of sec squared x is tan x, so we'll repeat this. Integral of sec squared is tan x plus k. So our answer is option B. You can see we factored. If you factor 1 over 3, see we are left is that, and we are left with 2 tan x. So the option is B. So let me now prove the formula I use, this formula here. We can write this as, integral of sec. Okay, let me just write it here so that this is integral. We can split this as n minus 2 sec squared x, because we want to use integration by parts. And if you could remember from integration by parts, that integral of u dv is uv minus integral of v du. So in this case, our u is sec x raised to the power n minus 2, and our dv is sec squared x dx. So the remaining is dv. So if you because we're going to get du and v from these two. So du is n minus 2 sec n minus 3 x, and the derivative of sec is tan, so we have tan x sec x dx. Yes, and we can write this as, let's simplify further, because we have this and this, so we have n minus 2 sec squared, that's sec n minus 2 plus minus 3 plus 1 is minus 2 tan x. So y v here is tan x. So let's now substitute in this. Let's now substitute. So therefore, the integral of sec x raised to the power n is now u v, which is tan x sec n minus 2 sec x raised to the power n minus 2 minus v minus integral of v du. So v is this and du is this, so we have n minus 2 tan squared x sec n minus 2x. If you multiply this and this, tan squared dx. Okay, this should be dx. So from Pythagorean identity, let's move. We can factor this. We can move this to 1 to sec squared. Remember, 1 plus tan squared is sec squared. So tan squared is now sec squared minus 1. So we can write tan squared as sec squared x minus 1 times sec n raised to the power 2 x dx. So we have, we'll write this, repeat that. Minus n minus 2. We open up this bracket. This times this is sec x raised to the power n. Yes, because 2 minus 2 is 0. So we're left with n minus sec n minus 2x dx. So we still, okay, so from here we'll see that, let me remove this so that you see what is, if you notice there is sec n x raised to the power n, and also there is sec x raised to the power n here. So what do? I factor. So we'll repeat the one on the left hand side. Why this one? This is minus, goes over to that side, is now plus n minus 2 integral of sec x raised to the power n dx. Yes, we move this times this is minus n minus 2 times sec nx. So if you move it, it's now plus. So we're left with tan x sec square x sec n minus 2 x. Why this times this is plus integral of as n minus 2 integral of sec n minus 2 x dx. So we have, so if you notice this plus this, that's if we factor sec x raised to the power n, we are left with 1 plus n minus 2, and 1 plus n minus 2 is n minus 1. So the constant is now n minus 1. We'll repeat this. So we'll repeat this. This is tan x sec n minus 2 x plus n minus 2 times integral of sec n minus, that's sec x raised to the power n minus 2 dx. So therefore what we are looking for is the integral of sec x raised to the power n, making it the subject of formula. So we now have divided by n minus 1. So I have integral of sec x raised to the power n dx is now tan x sec x raised to the power minus 2 over n minus 1 plus n minus 2 over n minus 1 integral of sec n minus 2 x sec x raised to the power n minus 2. So that's what we use in solving this. Do you see? That's the formula. That same formula it proves. That's what we use in solving this. The same thing. Check the same formula. So if you can memorize it, makes your solution very fast. So thank you.